talking about calculating concentration. So before we can calculate concentration, we need to go over a few definitions. So concentration is what designates the amount of solute dissolved in a quantity of solvent or solution. A solution is a mixture of substances that has a uniform composition, and a solution is made up of a solvent and a solute. The solvent is the dissolving medium of the solution. If you're not sure which one is the solvent and the solute, then you just sort of see which one is in the greater quantity. If it's in the greater quantity, then it's most likely the solvent. The solute is the substance that is dissolved in the solvent and is the one that is present in the lesser quantity. So concentration is important because the concentration of a solution can say a lot about how the solution will behave. And it's a pretty intuitive thing. The greater the amount of solute that is dissolved in a solution, the greater the concentration that solution will have. So, the three common ways of expressing concentration that we are going to talk about today are molarity, molality, and the mole fraction. So each of these express how much solute is in a solution, but they express it in different ways and in different units. So first we're going to talk about molarity. Molarity is the number of moles of solute over the liters of solution, and it's denoted by a capital M. So for example, if you had a 1 molar solution, this could be written as 1.00 molar with a capital M to represent molar. And so this would mean that you had 1.00 moles of solute for every liter of solution that you had prepared. So, for example, if you were asked to find the molarity of a solution with 5.00 grams of C6H12O6 in enough water to form 100 milliliters of solution, there are a few basic steps that you would take. First, we have to decide which component of the solution is the solute. So C6H12O6 is being dissolved in water to make the solution. So that seems like that is most likely the solute, and it's present in the lesser quantity, so we know that would be the solute. So molarity is moles of solute over liters of solution. So the first thing we need to do is find moles of solute. So we have 5.00 grams of C6H12O6. So we divide that by the molar mass of that, which is 180 grams. And so that gives us 0.027 moles. Next, we have to find the liters of solution, because again, it's moles solute over liters of solution. So we know that the C6H12O6 is dissolved in enough water to form 100 milliliters of solution. So that's how much total solution we have. So we have to convert milliliters to liters. So we have 100 milliliters times 1 liter over 1,000 milliliters gives us 0.1 liters. So to find molarity, we divide 0.027 moles of our solute by the 0.1 liters of solution that we've prepared. And that gives us 0.278 molar, with a capital M to denote molar. So, our next way of expressing concentration is molality. And molality is the number of moles of solute over your kilograms of solvent. So that's the main difference between molarity and molality. Instead of having your moles of solute over your total liters of solution, you have it over the kilograms of your solvent. And this is denoted with a lowercase m. So, say you were asked to calculate the molality of a solution with 0.100 moles of NaOH in 500 grams of water. So we know that your NaOH would be your solute. And so we already have your solute in moles, so you don't have to do anything with that. But we have 500 grams of water. So you know that your water is going to be your solvent. But we have it in grams, so we need to convert to kilograms. So 500 grams of water times 1 kilogram over 1,000 grams gives us 0.500 kilograms. So then, to find molality, we put our 0.100 moles of NaOH, our solute, over our 0.500 kilograms of water, which is our solvent. And we get 0.200 molar with our, molal, with our lowercase m to denote molal. So our final way of expressing concentration is called the mole fraction. So the mole fraction is determined by the moles of one component in your solution by the total moles of all of the components in your solution. And so this is denoted with an X and then your component written by the side here. So for example, in this problem, we're trying to find the mole fraction of NaOH. So we have X and then NaOH written in a smaller handwriting down here. So our problem here is to determine the mole fraction of NaOH in a solution with 2.00 moles of NaOH in 500 grams of water. So the first thing we need to do is find the total moles, but we can't do that until we have moles of water. So we convert 500 grams of water to 27.8 moles by dividing 500 by 18. So to find our total moles, we have to add our moles of NaOH to our moles of H2O. So for this problem, we only have 2 components to our solution, but for other solutions, there could be more, so you need to add all of the components together. But here we just have 2, so we add 2 moles to 27.8 moles to give us 29.8 moles. So our mole fraction of NaOH is 2.00 moles of NaOH over 29.8 moles of solution. Well, not of solution, but of the components in our solution. And then we get 0.067. So unlike molality and molarity, the mole fraction has no units. It's just 0.067 without no m's, no anything like that. It's just 0.067. It's not solid over solvent or moles per liter. It's just 0.067.